Okay, good. Julie says, lots of information. Cold. Challenge is a good thing. Anyone else? How do you guys see, how do you guys feel about, calling functions? Do you see yourself thinking about, ooh, what did I just write? Let me go back and sort of analyze it and see if it's efficient, or what's going to happen if the data grows, right? Do you see yourself thinking in those lines? Right. Or maybe, oh, thank you, JavaScript developers, for giving us these functions, especially yesterday when you had to create your own linked list, right? That's like a true developers. Imagine you're hired by the JavaScript community to create the linked list class and put it in the library. Okay, good. All right, good to see that some of you guys are enjoying, which is nice. So today is, again, since yesterday was I would say it was a pretty difficult day. Today should be pretty straightforward, sort of easy. If you have a good grasp on singly linked list and doubly linked list, that's what we're using today to learn yet two other data structures. One is called stack, the other is called queue. And as we go through these, I'll give you some information as to what they are. They're very, very heavily used in other languages, except for when it comes to JavaScript. We kind of bundle them all in array, right? So we took stack and queue functionalities and then put them in the array class, which in other languages you don't see them, right? So we'll talk about that, and then we will end the day by solving some interview problems using strictly stacks and queues, right? So again, you can solve these using arrays, but of course we're not going to do that. And from 12 to 1 today, you guys are invited to go to C18, cohort 18's capstone. So remember, you guys are with me next week, and the week after is a 1-week project with me. And then after that, you have Flex Week, and then you guys have 3 weeks of capstone. So cohort 18 went through that, and then they finished their 3 weeks of capstone. And so it will be really informative for you guys to actually go to it and see the teamwork, the final product, the work that's put into it, because you'll be basically walking their shoes very soon, okay? So 12 to 1, I myself will join them as well. And then that will be it for today. Let's see. Just to see, okay. You guys can see my screen all right? Okay. Great. All right, guys. Let's talk about stack and queue. So you can see these pictures here, right? That tells you the visualization, how to visualize when you're thinking about the stack data structure or the queue data structure, right? So we'll talk about how these two data structure works. What are some of the core functionalities? We will actually, at the end of this, you should be able to implement them and be able to utilize the class that you implement to solve problems, okay? So stack. Stacks are, when we think about stack, we think about the concept, which is known as LIFO, right? Last in, first out. So think about in a buffet line, right? When you go to have dinner at a restaurant that has buffet, right? And at the corner, you have these stacks of plate, right? So someone, let's say the person who's washing the dishes, will bring the plates, and the first plate, right, which goes in that stack of plate, is the last one to come out, right? So if you flip that, the last one that's going in is the first one to come out. So if you think of the data structure, not from a horizontal point of view, but from a vertical point of view, right? We're talking about things that are being put on top of one another, right? So therefore, in stack, all the work is being done at the top of the stack. So when we visualize it, we kind of visualize it this way. Of course, from a memory point of view, it's irrelevant, right? It goes in a horizontal way, but from our point of view, it helps us if we visualize this like a stack of plate, right, in a vertical way. And whatever data you put in that data structure, the first one that goes in goes to the bottom, which means that the last one that you put in the stack is the first one that you can retrieve. So all the work is done at the top of the stack. Of course, you can implement stacks. So stacks are not, the implementation is nothing new, okay? So we're not, just like linked list, where we used a node with the data and either one or two pointers to actually implement that. Stacks, we don't. We assume that there is an existing arrays or linked list, and we can use either one of them to actually implement stack. But we all know the drawback of using arrays, right? We're going to run into it. They are fixed size data structures. And so we're going to run into the expensive resizing, which will include the copying. So the common way of implementing stacks is singly linked list, right? So if you're so think about yesterday, we used singly linked list, right? And we had a label called head to basically indicate the start of our linked list. Well, we're using a linked list, but we're putting constraint on that linked list and making that a stack. So instead of calling the first item as the head, when we talk about stacks, we actually have a variable called top, right? Because remember, everything happens at the top of the stack. So instead of using the head variable, we use top, and everything is done from basically the top of the stack. Stacks are the common data structures that are used in low-level computing. So you guys have probably seen, if you have ever run into infinite recursion or infinite loop, you see the error message at the end that says call stack exceeded, right? So the reason for that is you have a function call, right? Or you have a loop, right? As the things are moving, right? It's getting, something is keeping track of what's happening. Something within the computing system is keeping track of which variable is placed in what location, right? Which variable consists of an array, the size of the array, and all that, right? And that's being placed in a stack, right? And then, so we call that the call stack. So in other words, if we have function calls, right? The function, remember in recursion, you keep calling these functions, but then one of these functions reaches the base case and then it returns to the previous one. Well, how does it know to return to the previous one, right? So there's a stack that's keeping track of, who's calling, who's making the calls, and then as each function returns, it's being removed from the top of the stack, right? So it's used a lot in low-level computing. Every time you declare a variable, the variable with its address gets put in a stack. Every single arithmetic operation that's done within in the computing system. So, for example, we could have a we could have something like this. We could say, well, let's see, X is going to be, here's my parenthesis, and within that, I will have A plus B minus C. So we can write these, right? But of course, underneath, right, something is interpreting these and giving us, evaluating this expression and giving us the value. Well, when you evaluate these expressions, you have precedence, right? Well, those, how do you know, in what order you have to evaluate something? How do you know parenthesis comes first? And then, if you have multiplication, division, addition, subtraction, and so forth. So stacks are used to actually take care of a lot of these low-level operations. There's a website called Stack Overflow. You guys have used it a lot. Has nothing to do with the data structure stack, right? So Stack Overflow is actually a computing term used in the hacking community a lot, right? So when you get the error message called call stack exceeded, right? That's a type of Stack Overflow. What's happening is the stack, it has a size, right? And the size is provided by the system, because otherwise you're going to take up all the available memory space and the other programs can't use it. So by default, each of this call stack is given a certain size in case if you run into infinite loop or you can't terminate the program. Somehow your program has gone into a state where it's continuously running, right? We will have a certain limit in that call stack. So if it reaches that, the program is going to shut down, right? Without the help of the program itself. So now in the hacking community, the way we can do bad things with this Stack Overflow, right? So we can exceed the call stack and basically put malicious code, right? And have that code basically take over your system and do bad things to it, get all your data, lock you out of the system. So Stack Overflow, or sometimes it's also called buffer overflow, is sort of a common way of hacking computing. We have measures against that now. It doesn't work anymore, but in the past that was a very common way of sending malicious code to people's computer. So the term comes from that, and of course the website Stack Overflow kind of borrowed the term and came up with a nice site for helping the community. Okay, so that's the concept of stack. Just like linked list, arrays, and such have core operation, and the core operations are, insert, delete, find. Stack also has core operations, and really it has two core operations. One is push and one is pop. So you may be questioning, you may be thinking, but push and pop belongs to arrays, right? We've learned that from arrays. Actually, that's not true. Push and pop, in other languages, you will never find push and pop as a function that belongs to the array class. It's not. JavaScript, when it started, of course, it doesn't have the concept. It doesn't have a stack class or a queue class or a linked list class. So because of the way JavaScript is used, right, for web development, there was not a need for a lot of the other data structures, right, when JavaScript started. Basically was used to do simple web development. Now it's more advanced because everything is web now, right? We need security on the web and such. But anyway, to begin with, right, it was basically assumed, well, push and pop are kind of method that we use a lot. Instead of creating a separate class, let's just add these functionalities to the array class, right? But if you move away from JavaScript and other languages, you'll never find push or pop as a functionality that you use in an array. So think about the array push. What does it do? it inserts something at the end of the array, right? Now I want you to flip that array and make it vertical. What do you see? You see that it's actually inserted at the top, right? So if you look at it from a horizontal point of view, I'm adding it using a push, I'm adding it at the end, but if I flip it, I'm adding it at the top, right? So stack, the push operation in stack is when you add something at the top of the stack, right? That's what push does. And there's only one spot you can use. You can basically do anything when it comes to stack. It's the top, right? Similarly, pop. So think about the array pop, right? What does the pop method in array does? It basically, removes the item from the end of the array and basically gives you what it has removed, right? It tells you, well, I'm removing this. Now I want you to visualize this in a vertical way, right? So if I want to remove something from the top of the stack, right, pop is the function that removes something from the top of the stack. Both of these operations are O of 1 because it doesn't matter how long your stack is, right? How many data you have, it just doesn't matter. In stack, right? As I said, it's a linked list, but with constraint. And the constraint is that you cannot iterate through the stack. If you have to use a functionality where you have to iterate through the stack, you're not going to use a stack. You're going to use a linked list, right? The stack, everything is on the top. So, for example, if I have a stack, right? If I have a stack of data, right? So let's say I have 4, 5, 6, 7, 8, 9, 10, right? And let's say I want to find 9. Let's say I want to retrieve 9 from this, right? I can't just iterate through the stack and say, oh, look, 9 is here, remove it. There is no such thing. What I have to do is I have to remove 4, 5, 6, 7, 8, and then I can remove 9, right? So it's not, in a stack of plates, you can actually remove something from the middle, right? That's real life. But think about the constraint. I have it in sort of a container where you can't just reach down to 9 and retrieve it. You have to remove things from the top, right? So you will pop, 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 and then you will pop 9. So therefore, both push, and same thing, if you want to push something, right, you would have to basically push, 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 push. So that makes those two operations of 1, because regardless of how long the data is, that particular operation is being done at one spot only, which is the top. Okay? So push pushes an item on the top of the stack, and pop removes it from the top of the stack. Any question on concept of stack, guys? Very straightforward, very simple. Okay? Notice that there's no insert or delete from anywhere else, right? Because you can't do that. Okay. Questions? We're all good so far? Okay. Good. All right. So let's go through some code and see how these two operations are implemented, right? So again, you guys are familiar with the node class, right? We have two parts of it, a data and then the next pointer. And the stack class, notice that it has one variable, which is top, right? Initialize that to null, telling me that the stack is empty, okay? So if you want to push something, right? So I'm pushing data. So notice what's happening here. I'm saying, okay, so if my top is null, which means my stack is empty, right? So notice how I push. I create a new node, right, with the data and null, and then I make my this.top point to the new node. So just like we did with linked list, like if you want to insert something at the beginning of a linked list. So this is the same thing except for it's vertical. Right? And if the top is not null, which means I have something on the stack already, right? So then what I'm doing is basically, creating a node, and I can just say this dot top equal this, right? That's fine too, depending on how you write code. So all I did here is I created a new node with data, right? And this dot top, which is my existing this dot top. So think about it this way. I have one on the stack already, right? So I'm going to create a new node with data 2, right? And I'm basically going to have its next pointer, right? 2's next pointer is going to point to the existing this dot top, which is 1, right? And this dot top, which is 1, it's going to point to the new node, right? So that's how I'm basically building the list. If I want to insert another node here on top of this, same thing. The stack is not empty, so create the new node. Let's say I want to insert 3. So 3 and 3's next pointer is going to point to whoever this dot top is, which is at this point is 2, right? So 3's next pointer is going to point to 2. And this dot top, which is 2, is going to point to 3. So this is how I'm building it up. Okay. So that's push. Very simple. Notice that there's no iterating through the stack or anything like that. You can only do work on the top. Pop. So what does pop do? Remember, pop removes it from the top, right? So how do we remove something? Think about a linked list. How do we remove something? We basically rearrange the top, right? So here I get handle of my top, right? And notice that the pop function, right, in addition to removing the item from the top of the stack, it actually tells you what it removed, right? So at the end, after the function call returns, it changes the data structure, changes the stack, right? Your stack has one less item, but it also tells you what it removed. So because I am removing the handle from top, I'm removing my top from what it is, the current top, to what's after it, right? What its next is, right? So I'm going to save that node, and then I'm going to tell my, whoever called the function, I'm going to return that data, that this is what I have removed. So if I want to remove 2 here, right? So 2 is my top now, right? So this dot top points to 2. I'm going to save this in a temporary node. And then I'm going to say, okay, this dot top is no longer 2. It's going to be 1. It's going to be nodes, right? Next, right? So my top is now pointing to 1, detaching 2 from the stack. And now I'm going to return node, which holds the value 2 and its data. Okay. Questions, guys, on push and pop? Make sense? Ask me question. Ask me if I need to repeat the explanation. Let me return this dot top if the list is initially empty. You mean this one?
Yeah, so like on the first condition, you actually return this dot top, but then on the other one, you don't actually return it.
For this one?
Yeah, for push. So like, if this dot top equals null, that means that the list was initially empty. So then you add the new node, but set the next to null.
Yeah.
But then return
actually, you don't have to return this. I have a feeling that I was probably debugging it and then I just left it there, because usually push doesn't return anything. It basically increases the length. It adds the data. So good catch. My guess is I was probably debugging it and I just left the code there. So it really shouldn't return anything. I know pop returns, but push doesn't. Okay, good. Other questions on Stack? All right, very good. Okay, let's talk about the second data structure, which is queues, right? So Stack is LIFO, last in, first out. Queue is FIFO, first in, first out, right? So think about McDonald's drive-through. Think about any restaurant you go to, bank tellers, right? You go in and you're standing in a line. If you're the first person who came in and stood on the line, right, you're the first person to be served, right? So as you come in, you get served and you leave in the order that you came in. So that concept requires you to work in both ends, right? Because so you're going to come in through one end and leave through the other. So that's why that's why a lot of the time we use doubly linked list to model a queue. So that I can use both next and previous, right? I can enter through one end, through the end, and then I can remove item through the front. Okay, so but you can definitely, especially in JavaScript, you can definitely use arrays to model queue, and you can use singly linked list to model queue as well. But in this case, we're going to use doubly linked list because it's actually a better implementation. Okay. As I told you yesterday, if you remember doubly linked list from yesterday, each node has a next and a previous, right? To keep track of moving between the nodes. And the list itself has a head and a tail, right? To keep track of the beginning and end of the list. And that becomes even more important when you're using a doubly linked list to model a queue, right? So how does queue work? So this is a queue. Node 1 came in first, and then 2, and then 4. But when I have to remove something, right, I remove it from the beginning, from the top, right? So remove 1 first, and then 2, and then 4. Again, 2 core operations in a queue. Okay, and here is something that I want you guys to keep in mind. Okay, terminology. Terminologies are important because it tells you what you're referring to, right? So when you talk about stack and you're referring to the insert and delete, right? Don't call them insert and delete, because insert and delete can mean that you're inserting somewhere in between, in the middle of a stack, which is not possible. Or you're removing something from the middle of the stack, which is, again, not a function that you can do in stack. So call them push and pop, because when you say, I'm going to push this, right? So that means they immediately know you're talking about a stack, right? So when those functionality comes to a queue, right? When you're talking about insertion and deletion in a queue, you should be calling them NQ and DQ. Because when you say that, then people immediately know, oh, okay, NQ, you're going to insert at the end. Oh, DQ, you're going to remove from the beginning, right? And they know that you're using the queue data structure. Okay, so it's actually important to know these terminologies. And I've seen a lot of students in the past would say, well, I'm going to insert this into the queue. You can't. You can NQ it in the queue, which means you can only add item in one place, which is the end of the queue, right? And you're going to DQ something, which means you can only remove the item from one place, which is the front of the queue. And these terms becomes really important when it comes to interviews as well, because if you're not using correct terms, then the interviewer is going to think, well, you probably know how it works, but you don't know which functionality belongs to which data structure, right? So get yourself used to using the correct terminology for the correct data structure, okay? So NQ is adding something to the end of the queue, and DQ is removing something from the front of the queue. And both of these are O of one operation, because doesn't matter how long my data is, I can have 10,000 data in a queue. I'm only going to insert it in one spot. I'm going to find the end of the queue and insert it there. And I'm going to find the beginning of the queue and insert it there. And that's why the head and tail becomes very important, because that tells me the location, right? I don't need to iterate through every single item in my queue to find the end, because as I am adding things to my queue, I'm updating my tail, right? So next time I want to add something, I'm going to find who's my tail pointing to, and I'm going to add it right at the end, right at the tail. Right? So that makes it an O of one operation. Same thing as if I want to remove something, I'm only going to remove from the head by changing the head constantly, right? So that's an O of one operation. Regardless of how long my queue is, the operations are always going to be O of one. Make sense, guys? Okay. All right, let's look at the core operations of Q, which is NQ and DQ. So again, I have a node class which creates my node. And since it's a doubly linked list, I have a value, which is the data, and then the next and a previous, right? So this tells me each node, and the Q class has, again, two variables. Again, call them head or tail. In this case, we're calling them first and last, like that's a personal choice, developer's choice. So in this case, I have it as first and last, indicating the beginning and the end of the queue. Okay. So NQ adds the data at the end. Okay. So I create a new node with my data. So initially it's my next and previous is null. Then I check to see if my queue is empty. So if the first is null, right, that means so if this dot first is null, which means the queue is empty. So then, of course, the node that I'm creating both gets first and last, right? So both of them is going to be first and last. Right? So if the queue is empty, this dot first is null, which means my first is going to point to the new node that I just created, right? I don't have a last, so my this dot last is going to point to the node. Right? So it's going to look, I have one node, this dot first points to that, this dot last points to that. So I have a queue of one node. And now let's add another node to it. This dot first is not equal to null, right? I already have a node in there, right? And it's going to check to see, do I have a this dot last? That's correct. I do. I just inserted one item in there, and both my first and last was pointing to that. So that means there's something in the queue. Then I'm basically going to, rearrange the pointers, right? So the node's next pointer is going to point to this dot last. Right? And this dot last previous, which is the node that's already there, is going to point to my new node, thus extending the queue with one other item. And notice that here I'm only working with this dot last, right? Which means NQ adds things to the end of the queue. Right? So with the exception of an empty queue, I don't really do much with this dot first, because this dot first still points to the item that was inserted first, right? Unless I dequeue it. So all my work is being done with this dot last. Okay. So that's NQ. DQ removes the item from the beginning of the queue. Right? It removes the item from the beginning. So first check is if the queue is empty, then, there's nothing to remove. So just return. If the queue is not empty, so just like pop, right? Pop removes the item, but also gives you the item that it removed. So DQ will do the same thing, right? It will remove the item, but then it's going to tell you here, this is the item that I removed. So it's going to give you the value of the item. So let's save that. Okay, so we can actually return the value of that, right? So basically saving the first node, and notice what's happening is I'm basically redirecting the node, this dot first to the node's previous, right? Which was basically behind it. So you have to think of this queue as from, let's see. So if you're drawing this, right, you're going to think of this way, coming from this side. And again, if you're thinking of it coming from this side, all you have to do is switch the first and last and the next and previous. So here is first, right, and then here is last. So when you go through this code, which I hope you will go through with your pair, keep the drawing as this. You know, this is the first and this is the last, and you're adding something here. Okay, so the last moves to this, and then the first stays here. When I dequeue, I'm going to move this. So my this dot first is going to go and point to this, like removing this one. And then I do want to check to see if I'm removing the only item that's in the queue, right? If it's the last item that I'm removing, then I'm going to make my last as null, right? Indicating that the last item has been removed and the queue is empty now, right? And then I'm going to return the value. So whatever I removed, that's what I'm returning. Questions on the queue, guys? Anything I missed? No. Guys feel comfortable with stack and queue? Thumbs up, thumbs down. Do you need me to go over anything? Code is making sense. Okay. So today, just like you guys did yesterday with linked list, and you guys did with arrays as well. So here are some things to think about. And I think I've given you guys pretty straightforward instructions. Yes. So I've asked you to create a stack and do some operations and so forth. So here in this case, I'm creating an instance of my queue class, and I enqueue, which means I add Tahita, which is the first item, and then Joe, right? And then I add Tim. So then I can display the queue, right? Just to see what's in there. So then I'm going to dequeue, right? So when I dequeue, I'm going to remove Tahita, right? So Tahita came first, Joe came second, Tim came third. So first come, first serve. So Tahita is the one who's going to be out, right? So then I will have Joe and Tim, right? So then I will enqueue Allison, and then I'll enqueue Chris. So then if I dequeue, right, Joe will be gone, right? And then I'm left with Tim, Allison, and Chris. Right. So today's task for you guys, stack and queue. So first part is basically, push and pop, try to write it from scratch, just like you guys did. It will also give you a really good revision on linked list, NW linked list for both stack and queue. And so the core functions of stack is push and pop. So you're going to use those and create a stack called Star Trek, right? And then you're going to add these elements, these items to your stack. And once you're done with it, these are supplemental functions, just like you guys did yesterday for display, size, and such, right? So peek is a really useful function for stack, which basically lets us take a peek at the top without removing, right? So pop removes the item, but we don't want to change the stack. We just want to know what's in the top of the stack. So that's what peek is for. So, and then display is strictly for debugging purpose, right? If I want to see what's in my stack, right? I don't want to move, I don't want to remove the items. I just want to see. Again, in reality, you should not have a displaying stack function. It's a supplemental function to help you write, solve problem. So I want you guys to see, if your stack is correct or not. So do implement the display function outside of the core. So these are outside of the core class, just like you did yesterday, right? And then you're going to remove McCoy from your stack. So remember the idea of removing something from the stack, right? Or if you have Kirk, Spock, and so forth, and McCoy is like down here, you cannot create a function that's going to remove it from the middle, right? You can only use pop to remove something from the stack. So just keep that in mind. And then you have 2 interview questions to solve. Actually, not three of them to solve using strictly stack, right? So one of them is palindrome, right? To given an item, right? Tell me if given a string, tell me if it's palindrome or not. And I know that you guys have solved this problem a number of times. You have solved this using string. So the easiest way, you probably did this before, is if I had dad, right? You basically read a string from the beginning and then read it from the back. And then if the string matched, then you have a palindrome, right? You've done this. But in this case, you're going to use a stack, which means this operation is going to be O of 1, right? So the core operation is going to be O of 1. So if you are not using a stack, right, if you're not using a stack, then you're doing something wrong. Right? If you're not doing push or pop, and you're just reading the string from forward and backward, then you're not solving the problem correctly. So just keep that in mind, right? You got to use a stack to do this. Same thing with matching parenthesis, right? As you're solving this, right, you've got to use a stack. So if you see yourself using, like basically iterating through the string and trying to match without using a stack, right, then you're not solving it the right way. And in this case, you're going to sort a stack, right, which, so imagine this is in a sorted order, right? So what if I just did this? What if I just changed this and said 2 here and then put like 9 here, right? So this is my stack and this is an unsorted one. And I'm going to use, and so you have to sort the stack. And notice it says you can use additional stack, but you're not allowed to use any other data structures such as arrays or linked lists, right? So you can use as many stack as you want, right? But nothing. So you can't say, well, let's take these and put it in an array, sort the array, and then put it back in a stack. Not going to happen, right? So just keep that in mind. You can only use another stack. Same thing with queue, right? Just like you did stack. So remember, these functions are actually provided to you. So I hope you have enough knowledge now to be able to write it from scratch. And then again, create a queue, add these to the queue, implement your peek function and your display, just like you did with stack, but this time you're using a queue. And then you have a couple of interview questions, right? Right. So here you're implementing a queue for this one, but not using a doubly linked list, but you're using 2 stacks. So you have 2 stacks, right? And you're using the functionality of you're implementing the functionality of a queue, which means you're going to insert something at the end of the queue and remove something from the beginning. Okay, again, you're not allowed to use a doubly linked list or an array, just your stack. Okay, and then there's a really fun exercise called square dancing. So we're making pairs, a female and a male. That's the only pair you can have to do this particular square dancing competition or whatever you want to call it, right? And so your queue can look like this. You have a male queue and a female queue. And so, but then it can come to a point where you have two males or two females, right? And then what do you do? Because one male has to wait, right? And then, or the other female has to wait. So then how do you pair them? How do you take them from each queue and then pair them up, right? And then the last one is, again, a common interview question. It's a bank teller problem, which is commonly used in queues to demonstrate queue. So you have a pretty bored bank teller who's going to serve, customers only if they have all the paperwork done, right? So again, customers are coming, first come, first serve, right? But then 25% of the time, so at random, right? Use a randomizer. So at random, all of a sudden, a customer doesn't have all the paperwork. So the customer goes to the end of the queue, right? And then, so then you're going to show how your queue looks like when you have that kind of items, right? Customers are being served, and all of a sudden there's a customer which does not have paperwork, so he has to go back to the queue, and the next person will be served. Okay. There is one more thing I wanted to say, which is at the end of your curriculum, that tells you that in JavaScript, as I mentioned, because the array class has push pop and it also has shift and unshift, right? It can you can actually use the JavaScript built-in array as a stack or a queue, right? And you'll see that a lot in if you're doing research online on JavaScript stack and queue, you'll see that people have used an array as a stack or an array as a queue because it has these built-in function, push, pop, shift, and unshift, right? So just know that it's there. It's not a good implementation because, again, you're going to run into the problem that you face with arrays, right? That's why we're implementing these using the linked list, so we don't have the fixed size problem, right? So again, you can't use an array today to implement a stack or a queue. So just don't do that. But just know that it's there. If you see the code somewhere in your research, just know that, well, there's a limitation in that code when you're using array.shift as a dequeue method, right? Or array.pop as a pop method in stack. Okay. Questions, guys? Are we all set for today? Okay, good. 1:30 review. We will do some, I will answer some questions, guys. So bring me questions if you have any. I would like to see at least one or two implementation of maybe the palindrome or the parenthesis, just to make sure you guys are on the right track and sort of give others some hints as well. And then I will do a status check on your job hunting process, right? Hopefully all the resumes are done. Hopefully portfolios have been started. So we'll discuss that a little bit, okay? Nice. Guys, see you soon.